inserted into the verses. For 20 years, I've been looking at them in varied sources, both oral and written. Researching oral poetry is not easy for many reasons. First, there are hundreds of songs still to be found in oral culture. Not travel like them, people will identify themselves with the flying cranes. But as it stands, the itinerary song, as we could call it, in Turkey, so that crane and man continue to support each other to reach their vital goals in this large and beautiful land. Thank you.
My name is the structure of my presentation. I will, of course, start with methods. I expect that's an illustration of the tag. So we have 24 satellites in the universe circling around the Earth. And this is one of the satellites, and these satellites continuously send signals. The signals contain time and the position of the satellite. And the tag of the crane can get the signal of the satellite and can calculate the distance to the satellite because of the time delay. So the tag of the crane also contains a clock, and due to the time difference between satellite and the tag of the crane, we can calculate the distance between both, which is illustrated by the line here. So now we know the distance between both, between satellite and the crane, but we don't know the exact position of the crane. There are many positions possible around the satellite, which is illustrated by the circle here. So we actually don't know where the crane is still. We know, of course, it must be somewhere on this Earth. It can't be in the universe, that's for sure, but we don't know the exact position. So that's why we need a second satellite, and we need also to calculate the distance between satellite and crane. The overlap of the possibilities by calculating the distance gives us the exact position of the crane. The crane saves the position of the crane every 10 minutes, 16 hours a day, from 3 p.m. to 3 a.m. to 7 p.m. Gives you to Sunny. Sunny is the name of our crane, which is marked by GSM tag, and it has the. In addition to the tag, it has a ring combination. Yellow, blue, blue, which you can see on the left leg of the picture here, and yellow, red, white. That is that are the colors. And it was marked on the 3rd of July in 2013. In its life, it came, as I said, from Western Pomerania, and then it flew in autumn. It flew to France. Unfortunately, it was a lazy train. Didn't come to Spain. But it overwintered at the Lac de Chantecoq and flew in spring back to the area where it came from. So here you can see the investigation period. So the area which is part of my study here. So our research questions were: first, which and how many roosting sites are used by the juvenile crane during rearing time? When does the juvenile crane leave, and when does it come back to the roosting sites? Is there any correlation between activity time or length of activity and length of daylight? And the investigation period of the study was from the 1st of July to the 15th of September in 2013, how we analyzed the data. You can see a map of Google Earth, and you can see also positions of the cranes of the 21st of August, that's just an example, in 2013. So So you can see, hold on, you can see here, this is the roosting site, and the crane stayed here from 3 a.m. to 3:50 a.m. So afterwards it left the roosting sites and flight to the fields nearby, which you can see in this red dots. So ABC, 3 roosting sites. Roosting site number 1, the field pothole. Roosting site number 2 was a wetland in the forest, and roosting site number 3 was a pond or a wetland in the field, a larger wetland. And you can also see that A and B are quite close together, but what are reasons for cranes to leave the original roosting site or the breeding site? There might be a change in water level at the roosting site, so when the roosting site gets too dry, there's not enough water, cranes leave the roosting site to be still safe in the night. Another reason can be food availability around the roosting site. So when there's no food around the roosting site, cranes might leave. In 2 nights there was a disturbance. So at the 13th of July and at the 24th of July we think that there was a disturbance because just in these 2 nights Sunny left the place and slept nearby in the forest, just for 2 nights. Next night it returned. You can see at least a picture of let's say the times. Here in green dots, the times Sunny has left the roosting site in the morning. In pink you can see here this line, that's sunrise, that are the times of sunrise, and you notice as we come from correlation and we know that sunrise determines the beginning of activity. Here we see in green now the times Sunny arrived in the evening at the roosting site, and in pink the line we see the times of sunset. And now we see no linear correlation between both. So what we see activity, the length of activity and the length of daylight. Here we can see on average Sunny was active 13 hours 56 minutes. There's which you can also see here on the picture, there's a length of activity, but only on shorter days. On longer days, the maximum length of activity is reached, which is in this study about 15 hours and 15 minutes. But I want to admit, or I want you to be aware that in this study we didn't include daily resting. So when I
German nature conservation organization and WWF, and we are supported. It's a big thing. A lot of people love to follow the cranes, and they would also like to fly with the cranes in autumn to the south, to France and Spain, where the weather is much better than in Germany or in other northern parts of Germany. I would like to present Wölkchen. It's another crane. It was not so lazy, wintering only in France. This crane came to Spain, so this nice, beautiful country. And this is one of the 3 juvenile cranes we marked with a GPS tag last year. Also at the 3rd of July, also in Mecklenburg, Western Pomerania. And it's also a male. This we didn't knew before. We also would like to mark the female, but this male was identified with a cooperation with a university at Greifswald. Yes, GSM tags. It's a solar-powered tag with this solar window. The mass is about 57 grams. And it's not only a GPS GSM tag, because then you don't need an antenna. It's also a kind of a radio tag, therefore you have the antenna. Then we can go active to the bird to find the bird to download additional data. Because with an SMS we only get 5 data per day inside the SMS. So, and we could program all the settings by ourselves. So we started, because we had no experience how to do the programming, how it's the energy consumption by the radio text. So we had to learn. In the first days with Sunny, for instance, we had information every 15 minutes. But with other cranes like Vulcan, we learned, oh, there are a lot of time in the forest, there's not enough light, there's not enough sun, and the energy decrease. And so we had to reprogram these tags. We had to go close to the cranes, about 200-300 meters close, and we could reprogram these tags. And now we got data in 30 minutes or in 1 hour time periods. So, additional data. Every additional data are stored inside the tag, and we can download this with a special receiver. So we were able to find again our crane Wölkchen close to Rome. But this is Rome in Germany, in Mecklenburg, Western Pomerania. It was there in the end of March in a flock of cranes, and we were able to download 36,600 datasets. So this is the data collection we used for analyzing the migration. Autumn migration of Wölkchen was between the 8th up to the 15th November, and we got data according to our setting from 6 a.m. to 6 p.m. because the battery the energy was very low, so there was some kind of a safety option mode inside the tag. And during spring migration, only in the first day, at the 7th of March, we had in a 1 hour period our data. Then the energy was much better inside, and we got information every 30 minutes last year. So I hope you can see the migration of Sunny, because the light is so high. It starts here in Mecklenburg, Western Pomerania, but only in small steps, less than 25 kilometers. So the real migration starts from Lower Saxony, crossing Luxembourg and France, the Pyrenees, and going there, wintering at Bocacara. The details about the migration phenology. The cranes migrated in average about 4.2 hours during the day. And they started normally in the morning about 10 o'clock, and then only some hours flying. So not a long time. We were thinking they fly for us a lot of hours per day. At least Wölkchen is lazy in flying in daily flight duration. So we have some information where they are roosting during the migration over Europe. And when we start our study, we were thinking, oh, they will go to Lac du Dère, they will go further on to Agisson, they will go to Laguna de Gayocanta, and then to the final destination in the wintering round. But we learned a little bit more. They start their flight in a bog in the Deepwater Moor area, and then they were still in the first day in Germany, in the federal state of Hesse. And in this place, they only roost in a meadow. And probably it was not a safe place, so they start very early at 7 o'clock in the morning. Then they stopped again on a meadow, not on a traditional roosting site in France, in northeast France. Then they overflow the Lac du Dère, and they stopped there in a lake close to Matou, 38 kilometers southwest of Lac du Dère. They continued to Agisson, but they there was another big thing. They migrated in 2 steps. The first step, they started the 7th of March of 2014, and they stopped in a small reservoir in Spain. They continued, and then they stopped in a really small artificial wetland, smaller than 50 meters, so no traditional place like Laguna de Gallo or things like this. Then they flew up to Argisson, but they didn't stop in Argisson itself. Then they had a break in central France for about a week, and then they continued another 3 days flying, a little bit more, in average 5 hours per day. During autumn it was only 4.2 hours per day. So let's have a look to the flight distances during autumn migration and during spring migration. I would like to start with the flight distances in autumn. So in the first migration day it was about 300 kilometers, and I think you can see in average it's about 300 kilometers as it was calculated. We had the 2 stages migration of the family, and during spring migration we had average flight distance spring migration, but there was no significant
difference.
Thank you very much. You are still wake up, it's nice, it's good to see. I would like to continue with the flight speed right now. So, the flight speed during autumn migration was in average 45 kilometers per hour. As you can see here, it's most of the time between 40 and 50 kilometers. The maximum speed was 64 kilometers during autumn migration. A week in central France. We were surprised about this, and we said wind is a real factor for migration, and so we checked the wind close to the place where they stopped the migration. There's a there's a station looking for weather factors. And I was looking there for the wind, and I checked always the wind condition at 11 a.m. And so at the 10th of March, there was a wind coming from northwest. So this could be the reason that the crane stopped, because they didn't want to continue flying against the wind. And this is okay. And also in the next day there was much stronger wind with 4 Beaufort in this day. But then in the 12th of March the wind was changing. It was in the back. So the birds would have tailwind and they could continue, but they still stay there. They still also the next days. And then in the last day, they could start earlier because we had tailwind before. But they didn't want to start, they didn't want to continue. So wind is not the only factor which affects the migration of cranes during spring and autumn, for instance, also. So there must be some other things. We have no idea if there was a really good food availability of a special food the cranes like to feed on, but it was not only the wind affecting the migration of the cranes. So there was no significant difference to fly about 140 kilometers without any safety airport in between, only water. And so the cranes did that they start here in Spain in a very high altitude, of about 1,100 meters. And then the next 90 kilometers, they used all this to get the energy for flight, to save energy, and then they continued active flying in a height of about 60 meters up to the coastline of France. What was interesting also, it was a high average flight speed over the open sea. It was about 60 kilometers, and the average speed during the whole spring migration was only 40, so it was half faster than the average over land, over this more safety possibilities to land on land. So now some information about the flight altitude during the autumn and spring migration. We had maximum flight altitudes of about 1,000 meters or up to 1,300 meters. So they started high because then they had the potential energy to convert this energy in moving energy. But then only in a short altitude, because if they have to raise more altitude, it's costly energy. So they only did this moving energy forward. There is no
Alonso, please, was here.
To look at the observation data to find out about, well, the new migration route that I'm talking about now. We are now collaborating actually with 12 countries, so that's a long process. We wanted to have finished this whole thing already, but it's taken a long time. And Johannes Wahl, he is from the DDA, which is like the German Ornithologist Union, and Hans Schmid. But then suddenly, actually, things changed when I started to look further for the data and noted the data. And since 2008, there started to come in during autumn migration more and more cranes. And in 2011, there really came more cranes. And last year we had about 2,000 cranes. And so I show you a second picture. Where I pictured the flock size, the maximum flock size. And there you can see that it's really actually coming more cranes, because last year we had the biggest flock for the first time with around 1,000 individuals.